welcome back to my channel. This is Geeky Engineer, and today in this video we're gonna review SpeedyBee F450 wing flight controller. So here's the packaging, in which it comes. It is branded with this B because of their mascot, and this is their website. Here you go. You can see the model F405 wing app and brand by SpeedyBee. So now we're gonna unbox it. I'm very excited because it's gonna automate my flying wing, and it came with lots of features. So in this box we got, first of all, this manual that we definitely gonna read. It's a quick start guide in which every port and every soldering pad is mentioned. There's a connection for dual rotor VTOL. Here's the pin outs for the wireless board. So the wireless protocol is basically a Wi-Fi ESP32 based, and in this box we got three boards. This one is the PDB power distribution board, this one is the wireless controller, and this one is the main microcontroller board. So this board is basically used just for the battery indication, and it has an ESP module in it, through which we basically do all the wireless updates. You can see it is ESP32 LoRa board. Here's the capacitor, and there are the jumper pins. Basically we have to stack all of the boards onto each other. So that's how the board is gonna be completed. This one is basically ST32 F405 ARM based microcontroller, and yeah, now it is visible. And this one is the SD card port for the black box. This one is the telemetry module, and on the back side we got these jumper pins. These are the basically silicon vibration dampers, and these are basically the pin out pads. Here on the other side we got the plug and play system. This one is for the cam, this one is for the VTX, and this is for the GPS module. This one is for the DJI VTX. Basically it's for digital video transmission. And on just below it we got the soldering pads. In case we don't want to do the plug and play system, then we can just solder through the pads. Solder pads are basically big, so that we can easily solder the wires into it. Here we got a 9 volt and a 5 volt. Yeah, these are basically 9 volt pads, a GND and an NS bus pad. This one is the indication on the direction of flight, and in this side we have to do the pin outs if you want to, in the box. Definitely we're gonna find a pin out jumper pins in it. So let's unbox the other side. So on the back it is clearly mentioned the firmware in which we can use in this board is basically iNav as well as Arduino Pilot, through which we can configure this board. The black box micro SD card is used as a black box, and MCU we have the STM32 F405 RGT6, and IMU board is basically ICM42688P. Barometer is the version is SPL06001. We have 6 UART ports, I2C 1 port, and ADC 4 ports, PWM 12 ports. These are the PWM ports for the signals. Yeah, so here the interesting thing is that there is no USB port in this board, so separately we get a plug and play based USB interface board. So in this side we have to just plug it, and we can configure it through wires. Here is the air speed sensor. If we are making a fixed wing, then for the speed measurement we have to use a air speed nozzle. So here is the connection for that. So now let's talk about the PDB. here we got the PDB, and in which like this one is for the battery and ESC. In this port we have to plug in the battery, and it supports maximum of like 28 volt. It's from 7 to 28 volt DC supply supported, and the current sensor maximally like can take up to 215 amps. BSC will get 5.2 volts, and we can use it for powering the auxiliary things like LED boards and all. Here also for it's written clearly we can use it for the VTX, camera, gimbal, etc. 5 volt BSC for servos is also given. Alright, so these are the modules we got into this board, and this one is the battery sensor, if it is visible. Yeah, so these are all the boards inside the box. Now let's see what's behind the board. So behind the board we got a quality check certificate, quality certifications, that is QC passed, and here is the box for the accessories. Alright, okay, so inside it we got these connector plugs, and we got the standoffs. These are the brass and standoffs with the silicone dampers. We got the wires and again the wires and the configurator. Here we got this one is the board with the buzzer, as well as for the programming of the board. Here we got the USB-C type connector, through which we can use it as a buzzer as well as the USB programmer. Here is the same output as in the boards given. This one is for the boot, so that we can like go into the CLI mode of the configurator. That's it, and let me put it back. Also they've given the two-side tape in case we have to fix it up for the permanent USB plug and play system. And at last we got these tiny pins which we have to solder for the PWM signals, like if we supposed to if we are joining the servos as well as the ESC, so that for that we have to go through the PWM support. So these pins gonna help us in that. Also we can use these straight pins. So it comes with two basically modes, one is bend mode and one is straight pins, and the advertisement which you have seen, which most of the guys seen, is in this straight pins. So that's it for now. Now the box is empty, and that's it for now. I hope you enjoyed the video, and if you liked it, then please do like, share and subscribe for more upcoming FPV videos. So on the other video, upcoming video, we're gonna mount it on our flying wing. It's basically a flying wing, and we'll do everything from scratch. So we'll do the mounting, we'll do the calibration, we'll do the mission planning. Everything will be done on this channel. So if like the video, subscribe and do share. Hope you enjoyed the video. Signing off. Bye.